In this reading, we are considering ourselves as data scientists, senior data scientists at MarketShed. MarketShed is an e-commerce platform which runs the e-commerce application that is hosted on a VPS due to cost reasons. However, MarketShed also owns a cloud platform, Google Cloud platform, where they can build and deploy their models. Specifically, MarketShed it actually leverages the Google Cloud engine, Google Kubernetes engine, so as to enable scaling. Scaling in that as users and as datasets increases, and also the model should also be given a chance to increase. Actually, the architecture which we're going to look at of Google Kubernetes engine is that it is developed to auto scale. And not just Google Kubernetes engine, any Kubernetes engine is developed to auto scale based on the requirements of a data scientist. So in this reading, you're going to consider yourself as a machine learning engineer who uses Python to do all those tasks. And you are going to be assisted by an already written script from the front-end team, which can be used to access and communicate to the app that is hosted on VPS. With that said, let's get to the ground. Tusikize kitu ground inasema. Now, remember we've been working with AI microservices all through. So we've been working with AI microservices all through. We've been actually decoupling it. We've been coupling it with the main application. Now, to make it a microservice or to ensure that it scales independently, by the way, that's the importance of microservices. Microservices are actually loosely coupled services or applications that communicate with each other through the REST API, representative state transfer application programming interface. So when they are decoupled or loosely packed together, loosely packed, this allows them to independently scale. So the AI model will scale independently while the main application scales independently. But when you couple them together the way we did, it's called monolith, and this one always brings up some challenges. The only thing that we need to know is that with microservices, cost increases because, as you can see, we are going to pay for the VPS and also pay for the GKE. But at the end of the day, the benefits are always huge than the cost, especially if the app is generating revenue. Like if hired at Safaricom, Masoko.com, or Jumia or Kilimall, I'll definitely advise them to use microservices other than the monolith. So what are we going to do? We are going to decouple the microservice into an independent project. Then in this reading, we are going to use Django because that's the name that I'm used to, the framework that I'm used to. But in most instances, you will find other people using Flask, which is lightweight. Others use another one called Fast API. It doesn't mean that you cannot use Django. If you are comfortable with the Django, why not use it? Just do it. Okay, so for us to use Django, we will have to go and create a new lineal together. Like in my case, I created it under MarketShed, and I created this new microservice called AI microservice. Where is it? MarketShed upskilling. This one, MarketShed upskilling model deployment. This is a folder I created. Then I started. So let me just simulate very fast what I did so as to ensure that we are on the same page when you are going to follow through. So you will come to market to a folder of your own liking, and let's say the upscaling this upscaling thing. So if I can delete this, then an empty folder like this, then open it with VS Code. Then in any Python task, not just for data, not just for deployment, not just for data science or model writing, for any Python task, always ensure you create a virtual environment. checking. Nope. I have a problem with WSL, so I'm using Windows. But you definitely run WSL, no problem. So this what reading assumes that you had pre-installed Python. So the only thing you're going to do, you're going to say Python negative M virtual environment, then ML deployment. The virtual environment name should always rhyme with what you are doing. Then hit enter. Then this one is going to take a few minutes. Once you see a certain folder coming up here, then this is the virtual environment that we're talking about. This virtual environment enables you to separate the components from the real global environment of the computer system that you actually, you see, at the end of the day, there might be conflicts. You may not want to use the Django in your computer, but you may only want to use the latest Django. So you need to install it only in the virtual environment, which means when you delete the virtual environment, it goes with all the requirements that you were created before. So it's going to take some time, no problem. And I hope you are doing the same. There is a place you are going to break, but the first step, I really recommend you do it. So once you see this, it basically says that it has been created correctly. Then depending on your operating system, like for me, I'm using Windows, you will see the scripts. This is what you should run. But for you will see the binary. So for you using a WSL, you should use source. You should actually type source, then ML deployment, bin activate. This is this is not going to work for me. For me, I'm going to use scripts. And inside the script, there is a file called activate. Here it is. Mine is called activate.ps1. So yours is just activate when it is in Linux. So p.ps1, no problem. Then I don't need the source for me in Windows. Then I just hit enter. Then if you see this, definitely it has picked up well. Then the second step is to pip install Django. By default, this is gonna install the latest Django, the latest version of Django. once it has successfully installed, from the Django documentation, so this is more of software development, but as machine learning engineer, we say during definition of our roles or as a data scientist, that you are more of a software engineer than a statistician, and more of a statistician than an engineer. So I'll go to Django documentation to help me through the process of actually building a project. So for me, I know, but I just want you to see what you can do. So user guide overview. Get started with Django. You can try a tutorial, Django installation guide. Oh, okay, you've installed, or Django documentation. Okay. Model standard admin site. I want the one that is to create the project. Okay, this one covers most of actually a lot as far as Nini is concerned. As far as development is concerned. For example, if you want to, this is ORM. When you want to develop models.py, you say Django DB import models, then class, the question. Maybe this is, they are developing an e-learning tool. The question text is a model of question, the text, and but before you reach here, you must actually ensure that you start somewhere. Writing your first Django app part 2. We need part 1. Why is it writing in first Django? I think what I want is in part 1. Where is it? Oh, yeah, sure. Thank you. Yeah, this is it. So this is what I wanted. Creating a project. When after creating a directory, which we've done, we now start this. This is what I wanted. Django admin start project, my site, Django tutorial. So if you start this will get a project called my site inside the Django tutorial directory. So in our case, we will call it a I microservice. So we will just copy this Django admin start project. When I was learning coding, I was told to type to always stick to my mind. So Django admin start project AI microservice. And where do you want it to be? So that it automatically it's going to be inside that. So there's no need of rewriting that the last part. So this one is going to work. Oh, okay. I'm writing it in the wrong directory, the one I had used before. Notice the Django admin with hyphen. Notice the start project being one word. Yeah. So after start project, that should follow the folder what you want, the project to be. Yes, but automatically Django is going to handle that, so there is no need. It's just like repeating yourself. You have time. The project should be. Then you just hit enter. So the project will be started, and automatically Django comes with the project intertwining, like a child of the main parent that you started. So there will be a project of the same name. This project of the same name is always or actually coming with the settings. which you are going to refine based on your need. By default, it comes with the databases. If you want to use PostgreSQL, you will change. By default, it comes with password validators, everything. One thing that should stand out that we are going to change is the installed apps. The installed apps are your applications which you are going to build as time goes by. One of them is actually what we are going to build right away. There are also middlewares. Middlewares are like settings, like connections that we want to use. So there's a lot of things, a ton of things that comes up. There is also one called the secret key. Secret key, which we are going to keep the secret key used in production secret. So Django has given us a secret key here. When you automatically during creation of a Django project, the Django comes with a secret key that is going to be appended there. Then allowed hosts will be the hosts or the domains that you are going to allow to access your app. One of them, for example, if you're working at MarketShed, it's going to be marketshed.co.ke. If it's you are working at Safaricom, it's going to be safaricom.co.ke. Let me surprise you. Even if you're using another, name altogether to expose the API, the settings are somehow close to being similar. If you're using Java, you're using Go programming language, using Flask, using Fast API, there is no problem. All of them actually serve the same purpose. So once we've done this, this is now where we are going to break. I want now to start going very fast with the ones that we built. This is called actually starting the environment, and this is a brand new application on its own. It's standing on its own. As you can see, we've moved it from the main app. The reason why we were developing this in the main app is to ensure that we keep all these models together, so that at the end of the day, these models, when we want them, we just now build for them their own AI microservice. But when the stakeholder needs to see them coupled together, they are inside the main app, but they are not doing nothing. They have no harm wherever they are. It is in this place that now they are going to cause more harm, especially if you do not build it well. Okay, so we come here. There is something I uninstalled. Okay. Oh, I'll have to restart, by the way. Sorry, I've remembered. Now, when I have a very nice README that's going to guide you in what you are going to do. This README is in the other project here. No, here in our main app. So this README is going to guide you on the steps that you're going to take until you are done. For the first time, I was not lazy. So the overview, the objective is to deploy the PCA and logistic regression model from the CHAN dataset implementation, CHAN PCA model, as a microservice on JKA. Then it should be exposed via a REST API and accessible by the main MarketShed Django React app that resides on a separate VPS. The components include the following. We shall have a backend, a Django application, which is actually an AI microservice hosting the PCA and logistic regression, and that's the one we are building now, with the REST API to serve the predictions. Then you're also going to have a front end, the main MarketShed React app, which will make API calls to the GK hosted microservice. Infrastructure, you're going to have a Google Kubernetes engine cluster for the microservice with Kubernetes resources like deployment, service ingress, and a CI/CD pipeline using GitHub Actions, which we're going to talk about in depth in each and every step as we move along. Then we're also going to have a CI/CD, which is always used to automate building, testing, and deploying the microservice to JKE. The teaching focus will focus on illustrating microservice architecture like independent deployment, scalability, and loose coupling. Then REST API integration and CI/CD pipelines. We are going to assume that the Jupyter Notebook is in the AI microservice folder within the MarketShed Django app, which we are building, the new one that is. Then the model and the scalar are saved as chan pca model.pky1. If not, you will use your own name and chan scalar.pkel. Then the main packaged app is hosted on a VPS. For example, DigitalOcean. For us, we are hosting it on WebHost, and uses Django REST framework for APIs. We are assuming that way. That's why, because the main market app is the Django REST framework, I decided to use Django to deploy. You have a Google Cloud Platform account with billing enabled, and the account Google account says SDK. That's the main reason why we gave you an email address for Market Shed, so as to make it official. You have a Docker and Kubecto installed locally. Kubecto is a command line tool that is used to communicate with Kubernetes locally. Then the repository is hosted on GitHub for CI/CD. You must host the repository on GitHub for CI/CD, and you're going to see how we are going to implement the CI/CD on GitHub. Then the fraud detection model and other models in a microservice are ignored for this deployment. And if you want to deploy them, you just follow a similar model, like a similar structure. And the good news is you do not need to start from scratch. You can just use the one that is already implemented, and you're going to see how we can just write for each and every model their own REST API. Then we call it a day. Today you are a real machine learning engineer. So yeah, but I just find fun working with the data, and the fact that I can deploy it, it makes you actually confident. Until Safaricom gives you a real world model to deploy. You start looking 3-4. So step 1, we are going to restructure the Django app for the microservice. This is microservice is the new girl in town, very beautiful girl in town, and each and every big tech companies are running on microservice. Let me tell you, nowadays, like MarketShed is a monolith, the MarketShed app, the e-commerce app, because of the cost. I told you microservice comes with cost. But you can find a company saying, you know what, we want to build a back end to be its own microservice peke yake, so that the team working on back end just focuses on back end. And that is not all. We can build a microservice with different languages, such that the team working on models can use Java and SQL, full stop. Then the team working on business logic, which are views, can use Go programming language or Python. So at the end of the day, this is also another microservice. This is how Amazon is building its components nowadays. Then we will create a standalone Django app called microservice for the PC and logistic regression model, decoupling it from the main MarketShed app. This ensures the microservice is independent and deployable to JKE. Our folder structure is as follows. A very beautiful girl here. The iMicroservice is going to have manage.py. By default, this is created by Django. So when you create Django, is going to bring this manage.py and bring the another AI microservice. Alafu wewe ndio unaongeza zako zenye utataka hapo ndani. For example, if we look at what Django has created here, Django has created AI microservice, manage.py, as we said, AI microservice manage.py. When you expand AI microservice, there is an init.py. This one can be empty, but must be there for this to be considered a module. By the way, if it is not there, wrong, you are wrong. Then we have an asgi.py. This is always used to ensure that we can serve Django and deploy it, like with the fin that we were using in MarketShed. Then the setting.py, like I said, is just used for app level setting, project setting. You set everything, and this is where you're going to do the settings such that the Django can communicate to the database. The Django can communicate to this Django microservice, the AI microservice can communicate to the main application and can communicate to the front end. Then the urls.py. The urls.py is basically the URL that you are going to use, which you are going to see, and in fact there is going to be another URL which you're going to define. Then there will be WSGI server. This WSGI server is always used to ensure that Django communicates over the internet using HTTP in a very, very effective way. Then the manage.py is a Django resource that allows you to perform some system configuration or systems testing, mic testing, ABCD as we move. And that's why you see run administrative tasks. One of them is management. And if you do not have Django, it will raise an error there. Okay, so more of this will can be covered if you decide to give MarketShed more of your money. If you enroll for the software engineering course. So for now, but the solid foundation is enough for you anyway. Yeah. Might be asking, when did you know all these? It does not come over a day, by the way. This thing does not come in a day. It is something that, yeah. So you have to be consistent. You have to believe in yourself. You have to forgo sleep. You have to go forgo sleep, and you have to like organize yourself. But like right now, I'm really juggling a lot, and I am also wondering how I am managing them. There are a lot. You are on XAI assessment. You know it's the date is very near. Then you are again on the building of the data engineering proof of concept. You must teach Shark how to be a very good machine learning engineer tomorrow. And again, the app is waiting for you. The sellers want you to visit them, and you are one person. But anyway, nothing came on a silver platter, even for the guys who are already established. Okay, so let me go through the app structure. This one up to here is called project configuration. The only one we are going to put more emphasis on is the settings.py and to some extent urls.py. Then you may want to add REST API, which is going to be used to communicate to our front end, and views.py for some more business logic. But why should we write business logic here? So this one is just going to remain empty as it is, because it is here that you can write the business logics in the main application app. And as you can see, we've imported the whole world to that. Okay, then okay, the readme. In the Chan, this is now at the heart of the business. We are so much interested in this. This is at the heart of the business. And as you can see, by the way, each and every folder you create, if you want it to be a module that can be imported to another, for example, for this Chan to communicate effectively with the AI microservice module up here, it must, and there is no compromise or there is no anything about that. It must have init.py, and it is just empty initializer. It's just empty, but it must be there. Then the models.py, these are the company models that are going to form the database schema. The urls.py, now this is the most important one. This is where you're going to define the URL that's now going to communicate, and you're going to see how it is defined to communicate the REST API URLs that's going to communicate with your front end. Then the Chan prediction model.pico, this is the one that is saved. I think we saved it yesterday. I don't know how it was called. We have scalar.pk here. So instead of it residing here, it's going to be cut and then brought here. So it will replace this here. Then we will be done. Chan scalar. We will just leave into Chan scalar. Then no new numbers nowadays can be. Let me speak. Hello. Yep. Ongewach. Yeah. So wachiki mara na gochi. Sorry for that. There is a day I assumed a number. Kumbe they were calling from a company that I was supposed to go to do interviews. I called. So later, I don't know what happened, that the person who was hired, she became pregnant and left without notice. Then they now started calling me. Then when I went there, they told me you was the one who was supposed to be hired in this role. But then I was working at Tech Savannah and I was loving my job at Tech Savannah. So and then I asked them. The salary was okay, 60,000 for a starting role. But when I asked them what I'm going to do, you're going to use Excel. I was like, Jesus, should I leave where I'm using Python and building machine learning models, even if I'm not paid? Sometimes you can forgo money for what is ahead. You don't just look at money. I told them, unfortunately, just in front of the HR, unfortunately, not going to take this job. They asked me why, yet you're giving you a very nice offer. Tell them the offer is okay, but what I'm going to gain in return is not in line with my career aspiration. And they told me, we are so proud of you that you are bold enough to tell us that. Please find someone who can use Excel. Excel, to be honest. I use it for cleaning. You guys want me to use it for building. Then I proposed to them Power BI. They told me that they don't want to pay. Yeah, okay. Predict.py. The purpose of this predict.py is to reorganize. You see the here when we were writing this inside, we wrote this inside a Jupyter notebook. So the nini.py is going to reorganize the predictor.py. The predict.py is going to reorganize all these codes into a Python script that can be handled by any production environment. So this one was just used to build the model. So all these codes are going to be rewritten to fit a Python script. Haya. We continue. Then the requirements of TXT, even a necessary CBE child nowadays knows what a requirement of TXT should hold. Same to Docker file. Of most important is the Kubernetes folder. This is going to hold the Kubernetes, what we call the Kubernetes manifest. The Kubernetes manifest are actually Kubernetes resources that you're going to use. One of them is the deployment. The deployment YAML file defines the deployment strategy that you're going to use, where you are going to deploy, what are you going to deploy, in what cluster, and what is the host. Then the service.yaml file. The services in Kubernetes, like the name suggests, are what you're going to use in addition to deploy, to ensure that deployment works. Then we have the ingress.yaml file. The ingress.yaml file allows you to ensure communication as far as HTTPS is concerned from the Kubernetes cluster to different applications like the market share main app on VPS. Then the configuration map, the config map in Kubernetes handles non-sensitive or non-secretive resources of your application. Then we have a certain folder called .github. Warning, if it is not .github, it is not going to work. It just have to be .github, and exactly the way it is here, it should also be in the GitHub folder. We are going to create it exactly the way it is here and also in the GitHub folder. This is also going to be done. Then we also have .gitignore, which is automatically created when you now change this into a Git folder, that is Git add. Then you know what the README file does. Is there any explanation we need to now do? Do you need that? Now, no explanation. I just want you to take your time to create. You see this thing here? We've created a iMicroservice alone. We've not added views.py, we've not added rest.py. We've not created chan and its files. We've not created Docker file requirement.txt. May you kindly take that time to do all this and ensure that your folder structure is as this. My friend, this is what is called software architecture. So you are building a software architecture. Yeah, I'm giving you, do it in the next 5. Actually, 5 should be given to someone whose head has Uji. But for Shaq, I think 2 to 3 will be enough. Yes, yes. May you kindly scan them together vile ziko. So you scan one, next page, the way they are. Zote pamoja. Hivi. Just scan this just for demonstration purposes. Just for demonstration. Just scan, then another one. So you delete this. You start over again. My main dream with Market Shade is to produce the next generation of machine learning engineers in Kenya. And actually, I'm using the format I was taught at IBM over Coursera. Those guys, and also the ones I always see via the internet, like YouTube. By the way, I love YouTube a lot. I don't know why, but I just love YouTube. Even while learning Coursera, when I didn't get anything on Coursera, I would pause, go to YouTube, watch that thing, do it, and if I'm confident enough, come back and now say, bring it on, baby. Let's now tackle, let's now fight. So I also urge you to make YouTube a very nice thing. The only difference between YouTube and all these ones just is that you do not have the evidence that you did something. But for skills, let me tell you, it pays off a lot. Yeah, YouTube is good. Then I just want you to, when you're done with the course and you're now confident, you can start building. You can now start building projects. Build as many projects, make them accessible via GitHub. Talk about them on LinkedIn. Just be mouthy on LinkedIn. Then also the best way you can get employed is not by building them and waiting to be called for a job interview. Otherwise, HR has their own people. So the best thing you do is to connect with HR professionals, senior software engineers, and machine learning engineers on LinkedIn. Just send connections like a madman, a lot of them. Then when they accept your connection, go to their inbox, talk about your projects, give the link if possible. Then you propose what you can do, how you can answer their problem. Just say, for example, like in this case, I deployed a Chan dataset on Google Cloud, Google Kubernetes engine. Maybe I looked through your company and I realized that your company does ABCD. I can come over and help your engineers deploy this Chan. And it's not just about deployment, it's deploying it in a microservice architecture. Then you explain just to demonstrate your knowledge of what you're doing. Otherwise, if you are going to wait for employment by HR, you'll grow old waiting. Well, it depends with the company. If you look, for example, one day if we are a big company, that is, and you as Shaq may be the CTO, then on LinkedIn, you know very well what we are struggling with internally. We've not exposed it, but we know. Then a certain machine learning engineer comes to you. Let's say we are struggling with what can customer segmentation. Then this guy tells you, I built this model that segments customer based on the regions, and I found out that MarketShed is an e-commerce that can benefit from this. Very fast, even you as the CTO will be getting that urge. Acha niite huyu kijana nione kitu alibuild. Then you will tell him, may you kindly come over, or may you kindly send your project so that I can go through it. Then you send them their assessment. When they pass the assessment, call them for the interview, and that's how people get jobs. Now, otherwise, if you're going to wait for HR, the opening, oh, oh, just be patient. You will have people from here. Yeah, easy call. Don't create it. Don't create it. Yeah, it's just telling you that this is a folder that remember this is going to be a GitHub mini. So GitHub will come with these own resources there. Very good. So the services that we are talking about in Kubernetes manifest can be databases, message queues like Kafka. You can define Kafka that streams data to Nini. So recently, my former company was hiring for the Kafka streaming developer role. Look, I was interested, but I said, if I apply for this role, I'm going to be a madman. Let me just suffer in silence. Let me just suffer in silence and swallow my humble pie. And I don't know. It's just that washanitoka kwa roho anyway. So, okay. Pardon? Yeah, actually, they were actually surprised. He told me that they were surprised. We were asking ourselves, where is this man going to? Who just resigns? Then baadaye wanaona LinkedIn talking about market share, the app, nini nini. Oh, so this is what was driving him crazy. And I am told that after that, they implemented an ini that all the employees must disclose their projects. They did that. Okay. You know this thing is going Shark, this thing is going over to the YouTube channel. But thanks God I didn't mention the name of the company. So we shall discuss about that after we finalize the class. So we convert Jupyter Notebook to Python scripts. We extract the prediction logic from Chan into predict.py and set up the REST API. You know what pandas does, you know what numpy does, joblib and juggling. Now remember, there will be the input data. That's the input data is actually what will come in from the data frame, the data that will go to the SQL or any other place that our data resides. In this case, we just imported. But the input data is the data that will, the new data that will come in. Then from the input data, we will get their columns. So joblib, look at this. We saved it from, this is the reason why you are saving. So we are picking just from where we left yesterday. Yeah, so we saved it here. I told you that market shed will be purely practical. So we saved it using joblib.dump. Then from where we left, during deployment, we now change it into a Python script by loading it. You see all these things that are up here have been actually saved. There is this one I want to use. They have been saved as what do you call it? Okay, if I remember it, I'll say I'll it's just coming and then disappearing. Like, it is not saving them as exactly the codes that you see, but it's somehow encapsulating what the codes are, then saving it as just a pickles .pkl. Then after that, we now load them in the data, just from where we left. On where is it? Yes. So when the point where we were, that was testing, and thanks God for calling it testing, and that's why it is not in our deployment, it is in our building, because we were testing. If we go back here, you see here, this one here, it was for testing. So for the real world scenario, that's what we are now doing. We are just using the same classify new input and by loading. So the new input that is now going to be served via this one, REST API.py, is this new input that's going to be served here is the one that's coming from the customer or from the database now. This is not now for testing. This is now the real world scenario. So we are going to copy this into REST API.py. So when you move to our model, you will come here, REST API.py, then paste, then save. Yeah, that is done. Remember, numpy and everything must be defined here in the requirements.txt. So numpy pandas. We continue. So question. Yes. Yeah, whatever we built yesterday and tested, and that's why I told you, because cautious before we deploying. So whatever we built here and tested, you see this testing at 90. So any prediction that is going to be made will be made at 79.13, and that's the work of the joblib. The joblib dumped our model as a pico here. Then the same joblib, actually after dumping it, chan pca.lr.model.pico is the one that's now loading it during deployment here. Here, joblib.load, and it's calling it the model, and of course it's the model. Then the scaler, which will allow us to scale as model adds in. This is actually an inbuilt feature that as model comes in, we can continue or proceed with the scaling. Then our function that's going to do this is now here. Yeah. Then we also have the REST API. Uh, extract the prediction logic from into predict and set up the REST API in REST API. So we set up the REST API here. Goja. No, this one should be in predict.api, not rest.api. So let's change things a bit. This one should be here. Okay. Predict, because it is predicting. Then this one is the REST API. Sorry. Now the REST API, the chan prediction, is actually a post request. A post request meaning it is coming from the client who will post something to our model. And the reason why we're saying it just must, there is no compromise about this. Expected columns for training data, it must conform or rhyme with the columns the way they are Huko. Otherwise, it's not going to work. And notice what has been done. It must work with the one hot encoded columns. So senior citizen, tenure, monthly charges, total charges, gender male, partner yes, department yes, phone service yes, multiple lines no, phone. You see all this all the way up to the check. So it must just rhyme with that. And this is now what you are predicting. I want us to talk about some things. From REST API dot views import API view. API view is an inbuilt Django class that, as you can see, we are inheriting from it. We are defining our own custom class, but inheriting from API view. This API view has inbuilt HTTP request that allows you to interconnect APIs. So API is basically application programming interface. So inanga vitu mingi, just defining and a few HTTP requests. Then, of course, the self to identify our method to the class. Then the request is now what we call the argument. So the input data is the request.data, the request that comes in. And this request.data should have the following columns. Then the prediction and the probability will be you should classify new input based on the input data and the columns up here. But where do we get this classify new input? We import it from predict import classify new input. And because they are in different folders, you ought to say chan.predict. You see now Quakalarize immediately. So from chan.predict, remember this one cannot work well if you do not have this here init.py. So when that is done very well, now you can now input classify the new input based on the incoming input and columns. Meaning, before you write all these columns, you must just come back and look at your one hot and correct data to ensure that the columns are what they claim to be. Otherwise, if there is no prediction, that's the prediction and the probability. If there is no prediction, which saying if the prediction is none, return prediction failed with an HTTP status of nil. Where do we get this status from? Django has an inbuilt method called status that is also gotten from a REST framework method of Django. So once you install Django, it comes with the REST framework. This REST framework allows you to import status. The status that we're talking about are the HTTP status that's like 500 server error, 4,400 bad request, 401 large resource, 201 successfully created, 200 can be accessed, things like that. Otherwise, if there exists prediction, you return the predicted churn and the probability of prediction. Then because you have returned it successfully, that's an HTTP request 200 and it's okay. Then, but if all these cannot work, just print the generic error. This is the error that comes from the server. Maybe something is not working well. That is REST API, and we are done with it. So let's look at how REST API borrows heavily from our model. And it must just be in sync with our model. Otherwise, you are not going to otherwise you are not going to get the best result. Yeah. Remember, we are stopping from exactly where we left. We are yeah, so meaning if you had done one hot encoding, we are no longer using the previous data, we are using the encoded data. Okay, so things are going to boil now. Okay, but I hope not much. Okay, we are done with the prediction with the REST API, and we're done with the predict.py. Now, after defining the REST, actually the first one that you're supposed to define is the predict.py because REST API borrows from it. So predict.py, when you come here, you classify new input. There is no need of talking over this and this over and over again. Why? Because predictor.py is the one that is introducing us to the deployment by loading the model and classify the new input. Then after classifying the new input, the REST API actually takes from it and ensure that we can predict the churning out of a client. Then the next thing, I told you the credit. Let me take this to 1 second to brag. Credit, Market Shade Upskilling Center Programs Coordinators. So explanation, the predict.py will load the model and scalar, then defines the classify new input function to pre-process and predict. Then the REST API will create a Django REST framework API view to handle post requests with input data, then return predictions. Then the REST API enables the frontend to interact with the model. Very nice. So DRF simplifies API. Now, before we even go to configuring Django setting, for the app to access this thing, we need to define the API. The URL. The URL we're going to define is the URL that resides with the REST API churn prediction here. So this URL here. So you will come URL patterns. Look at this. Just copy whatever Django has given you first. Copy it. Put it here. Then it is always advisable you start with API, the word API, then predict, then churn. So you predict churn. What are you predicting? We are actually predicting views dot when you start writing views, you realize that it's not there. Why? Because you've not imported it. So we need to import it from REST API. So we just say from .rest API import. What is in REST API is this one, churn prediction API. So just come and paste it here. Views.churn prediction API. Sorry. See, not views. REST API dot as underscore view. There is a problem. Oh, no, not here, please. Sorry, not here. It should be in this other URL, the project URL. Wait. There also, pardon? It's this one that will now communicate to the front end. And let me just, there are others which we need here. This one here. From Django.urls, import path. Which path are we importing? The one that is automatically picked as Django.urls is actually this URLs that we were trying to, this one here. So it will import a pre-built path. So this path must also be imported here. Then from Chan, this one is AI microservice. From AI microservice.api, import that. Then is when you can now define the URL patterns. Okay, when you're not sure, just come to the documentation. Iko hapa URLs.py here. See, there's this one. This is how, and I told you, if you need, you can type if you have time. Right now I don't have that time anyway, so I just paste. Once I've pasted that, I can, so we do not have views for us there. So what you're going to import is AI microservice dot chan dot REST API. We are importing Chan prediction API. Yeah, nice. This one must be there. Leave it the way it is. The home should be left the way it is, as well as to communicate with the front end file. Then this one should be fine. Okay, I'm going to debug it. I know where the problem is. API predict Chan. But I hope it is implemented down there. I'm going to find it. So Chan prediction should be dot as view, if I'm not wrong. From the documentation, if you have, not that one. Models. Let's find it. Let me just use mine that is already existing. Should be dot as view. So I want you to see something. When you are writing views.register user, which means the register user was defined as a function in the views file, you do not need to put as view like this. But if you define this as a class, you must include as view. That's a must. So that is what I wanted the documentation to show me, but it is not giving me what I want. And I'm really don't know why it's not picking up here. So the name should be something that describes what you are doing, like Chan prediction. I'm a predict Chan. Okay, where you have the API prediction. Here. Oh, here. Oh. This is just your own. By the way, this is your own way of writing things. You as Jack can write it the way you want. The only thing you must ensure is that when frontend want to access it, you write exactly the way it is, the way you put this part. This one is user defined. This one here. So this one is user defined. So the only thing you need is a path, how the frontend is going to access it. And that's why you see when you Google for market shed, and let's say you look for a product, you see it's market shed slash products. So the same thing applies to you for this. If it was the same thing, it could have been market shed slash predict slash Chan. So how the front end is going to, this one stands for the front end, this one here, while this one stands for what you defined as the URL. But let us move. I think the folders defined is very well, so we can just move on with the folders definition. Step 3, we now configure Django settings, update settings that try to include DRF and cost for front-end access. For example, our setting is the secret key is equals to get environment Django secret key, then your secret key. But our secret key is here, so there's no need of rebuilding. If you come back to our app and look at the settings that by default Django had given us a secret key. So that's what we are going to work with. The next, we also have things like debug or else that this is very, very important. Very, very important. So we will copy it and put it inside here. Change to to false in production environment. Is it false or true? I guess it's false. Debug is true. Yeah, don't run with the debug turned on in production. This one is just like the name suggests, it is helping you to debug the app. So are you going to debug the app in production? No. Allowed hosts are those hosts that you you are going to use. For example, if you say everything, it means that all hosts can be used. Star stands for everything. Alternatively, you can just put 0.0.0.0/0. That also stands for everything, meaning each and every IP address should be allowed access. So for now, let us put everything to prevent errors. But in a real world environment, during production environment, you are advised to do this. Update with a GKA external IP or domain in production. For example, in our case, if the backend had another domain like backend.marketshed.co.ke, that's exactly what we could have done here. Nimekuja hapa tuseme backend.marketshed.co.ke. That is one. That is our main app here, MarketShed. But we might also have the one we're now going to deploy, which Google will give us. Let's say Google will give us and say www.google.apis.gke cluster slash deployer ama ml deployment, based on how you're going to name it. So these are the ones that is allowed. Remember, if you put something that is wrong, it's going to throw an error. Kama hiyo hii ingekosa, it will throw an error. If it is not, if this one does not exist, like right now it doesn't, it will throw an error. So to prevent that error for in the development environment, what do engineers do? They just put that. Except that some engineers are always funny. Some engineers will always leave this to production. Very, very dangerous, especially for hackers. Will access your app very fast. Tunasonga installed apps. Things that you install. Number one app is your app alone. One is Chan. Number two, the second app is the REST framework. So we install the REST framework is another app, the Django REST framework, and we install Chan. All this must be included as installed app when you are continuing with consideration. And that's why the core headers must be there, the REST framework and the Chan. These are our applications. You just copy them and put in there. Core headers, what is the work of core headers here? The core headers actually helps you with security. This is now cybersecurity part of it. They allow you to implement security, and that one will be followed by allowed course, I think somewhere, if I'm not wrong, so that when you said that the allowed host was not part of it, the core headers is the one is going to implement errors. When I still did not know about this, I really struggled with market share, and I was like, what's making this app not running? Kumbe, I told the app that you should only allow for market shed and origin should only be from market shed alone. So when I was trying to get access from www.marketshed, which is different from market shed, then everything was going hayway. But it's good for security. Then your app, if you don't put your app, it's not going to work. So the next part are the templates. All these should be the way they are. Now, WSGI application should be this. You should put in this, the WSGI application as a microservice.wsgi.application. Let me put it so that you can come back and explain why we are putting it there. Oh, it already existed. By default, during creation, Django will create it because it will access that from a microservice, we have the WSGI. Then inside the WSGI, this is where we have the application here. And this application calls a get WSGI application, which is an inbuilt Django application. The work of this, it doesn't have anything else. It's just to ensure that your app can be exposed to the internet. All these camps are pre-built with Django. What's funny about us, those of us who like using already built frameworks, we do not even care about knowing what it does. So may you kindly go ahead and view the documentation. The documentation is always your savior when it comes to building a model and deploying it. And by the way, if you thought you are done with machine learning during training it, I think you had just done 10% of the task. Okay. Yeah, because deployment hapa inakwanga na maneno, we will finish it, set up CICD, then monitor. Okay. But I hope you are moving on well and you're getting the concept. Yeah, I'm getting. Okay, now the database. Kindly ensure you change the database if you are not using SQLite. SQLite is a lightweight database that is used for testing. Well, if we were to use the real market shed app, we could have put in the database, our database from the production environment here. But we're not using the real app. We are just using the data from If you see this setting, this is the setting in production now. You see how it keeps on increasing as time goes by. All these, some of these things, just like you're seeing them here, I'm also seeing them because I ask AI, gives me, I paste. Life continues. So I wanted to explain what the database. So like some REST framework, if you need the app, like here I told that if a user stays in here for 200 a minute, please, like the user can only stay, I don't know, 200 is what per minute, I can't remember well, but if it does happen, log them out. And if you're using market shade app, it does that. Okay, so this is it. If you're using a different database like PostgreSQL, or you're using a different database like MySQL, you can write it there. And by the way, this is always gotten from Django documentation. So you are the one who's going to implement the name of your database, the user, the password, the host, and the port. Okay, so in our case, let us just stick to the SQLite, the SQLite database that has been given. Yeah, then we continue. I know where the problem is going to, the rain is going to start beating us. For now, it's just okay. So we add REST framework and core headers to install apps, configured cause allowed origins to allow requests from the React frontend. Why is it, by the way? Cause allowed origins. That's very important. I told you we should do that. Allowed hostname from that middleware. Cause allowed origin, yes, is one. So this one is also the same thing like I told you. You must uh, explicitly define where the app should be. Mostly we always put it after allowed host. So we must always define where the origins should be. For example, if you want to allow origins from React frontend, mine is https www.marketshade.co.ke. I told you, like just like the name suggests, this is just, you must do the settings. So that's the React frontend URL. Now, when you are a machine learning engineer, you will put in our React frontend which you're going to use, and not just React frontend. Let's say this one was used to the admin is the one who's supposed to see it. Then only the admin is going to see it. Otherwise, no one else. But this is not recommended because it might throw some errors. So just stick to this. Yeah. That there are some names that have been hidden to the admin. For example, if let me give you one. Let me log in with admin account. This admin of MarketShed. So when the admin logs into this site, can access the admin dashboard. Of course, it's even shown here. So you can access the admin dashboard and you can see the company, everything, the sellers, and what is happening as far as the app status is concerned. That is a frontend that is only used by the admin alone. So let me log in with an admin account. My account. So when an admin logs in, and first of all, if you try to access, there is nothing like admin dashboard. So when you try to access the admin login, hit enter, you are being told that unauthorized access to admin roles only. So inakuramba hivyo kidogo. So you are answered, sindio? Okay, so the URL patterns. Now define URL routing. Route API request to the churn prediction API. from Chan import REST API. Then this is what I wanted. REST API.chan prediction. Yeah, exactly what I wanted. So we copy it and take it to the application URLs. By the way, there are two URLs here. One URL is called the project URL. This one configures the project. But the application URL is the one that configures the application. So this is it. Why is it not importing the? It should work. It should work. Let me change everything altogether. But it should work. I don't know why. From chan.rest API import. But this one should work nevertheless. Oh, from AI microservice. Oh, this one. That's what we are saying. Okay. Very good to teach people like you. I'm making my work easier. You see, when you smear oil on a slope, then put a very huge rock, it rolls alone. From AI microservice. Why is it not yet? REST API. Tuone kama tumeadd. Then it means there's a problem somewhere. Let me see. From .rest API import chan prediction. So that chan prediction dot, yeah, that one works. Okay, that one works well now. This is what I wanted. If it doesn't colorize, probably it's going to land into an error. Okay, so the next one, that is, we maps API chan predicts to the chan prediction API view. URL routing directs the HTTP request to the appropriate view, enabling RESTful communication. We are done with everything setting, so we are starting deployment. Is there any question up to that point? Okay, so we can continue. So this is where the deployment part comes in. For you to deploy, you must have Docker installed. So it's going to log me out for a few minutes, I don't know. But let me see if I just close this Nini and restart. So save. If it logs me out, well and good. If it doesn't, also well and good. Yeah, so Docker. Then we open it again. But I hope you are enjoying everything. Like me when I was really starting out. Am I talking alone? Are you there? This is the wrong one. Shaq, are you there? Shaq? Oh, come on. Sorry, it threw me out. I thought I was talking to you. I was talking to myself. At your work email address, do I even have one? I don't know. Okay, the email. Let me log in with this one here. Continue. Then continue. Then continue again. Then proceed to desktop. Then open desktop. Nice. See, open. Okay. This one wants to joke with me. Yep. Starting Docker. Hey, Docker. Reminds me, I told you I'm a director of a church play that we're taking to the festival. So there is this lady from the Kamba region. Actually, the script says she should have a heavy Kamba accent. You, you might think God brought her because she's a new entry into the team. Very, very heavy Kamba accent. Like even calling Monica. Hey, we always laugh. Like she makes the play interesting, by the way, because of that. Okay, so just a minute as the Docker engine starts. So as you can see, the Docker file does not now throw an error because the Docker engine is. Yeah. Okay. First things first, we ml deployment /scripts. So I was looking at a certain post on LinkedIn. So apparently this guy says that he was hired as a senior data engineer. Then he was told that you will be using Windows 11, no Linux, no Unix. He was supposed to please reduce the background noise. He was forced. He says he was forced to decline the offer. Yeah, mbona why error? Because there's nothing yet, I guess so. Containers. Yeah, so I thought it will come back with my containers. Like I uninstalled Docker, but because of my sign in, I've not signed in. If you use the account, there is no problem. Okay, so now we start the deployment things. And after writing, I think time payment asana, we will stop it after looking at Kubernetes theoretical approach, so that tomorrow we have a makeup, we pick up from there and make sure that our app is running on GKE. I know you can't wait. By the way, I didn't tell you Friday I have we can just have it on Saturday then, but very early in the morning because on Friday I've been called for a data engineering interview for Safaricom. Yeah, it came as a surprise to me because I just applied it jokingly, but like I said, like I told you before, I also looked for someone from the Safaricom team. It works, by the way. It works. It works. What I was advising you. Why did I forget? The way I'm always mouthy about such things. Yeah. So they have called me for that data engineering. Then data engineering platforms engineer, meaning I'm not just data engineer. I'm building things. Kusha mimi. So I have to prepare. So if we stop today, we will just meet on Saturday very early, like 8 a.m. Because at 10 a.m. naenda direct your play ya church. It's actually giving me a lot of headache because we are supposed to go there in a month's time. We are not yet prepared. Nothing has been. Hey, so it's really giving me. But the youths are wanajituma sana. That's what I love about them anyway. Okay, so we continue. I told you that Docker file starts from the keyword from. From actually defines which base image you are going to use. I hope you can remember all these things. So I'm not going to repeat. I'm just going to go very fast through the explanation, but not going to repeat everything from scratch. From we are taking the Python 3.10 slim base image. Oh, this is the best one that every data engineers always use. I don't know why it's always just this, but we always use, like you can see, from base image tag, and base image at digest. So we use from Python 3.10 slim. Then the working directory. This working directory is not necessarily the one here, but it is the directory that where your app will be across the platforms. Remember, this Docker image can also be used to deploy app on VPS, deploy app on on-premise server, which means that if it is on VPS, it will be called, it will be under the app directory on VPS. Hata kwa GKE, it will be under app directory. So taking us back to where we were with trying to implement the allowed origins. Remember me putting there /ml deployment. So it will be /app. Then copy requirements.txt. This one here is incomplete without the full stop. And it does exactly what you are telling it. Copy the contents of requirement.txt and bring them up into the, which means that requirement.txt should be complete. I think tunaijaza hapo mbele. Let's just continue. Then after copying all the contents, you install them. Run pip install with no cache requirement.txt. In fact, you can even this is optional, but don't miss to put this. It will lead to an error. What this one does, every place you tapeleka this your project, Docker will install the requirement.txt automatically, and you're going to see how GitHub Actions help us with that. Like, the only time you are going to use a lot of energy is this first time when you are deploying your app. After that, everything is just going to be very smooth. Like, I'm really enjoying teaching this course anyway. Then after that, you also again copy everything in the current directory, and the double trailing means you copy everything in the current directory and again copy everything in the current directory. I hope you are understanding. For example, copy everything in the current directory being a microservice, everything up to a requirement.txt. Then copy everything inside it means that you are going to copy init.py, everything again like that. Yeah. Then command to run will be unicorn. We can use Dafin, like in my app, I'm using Dafin, but unicorn is also okay. So the command that is going to expose it over the internet, or that's going to run it, is unicorn. You must bind it with port 8000. This is the port for. By the way, you must expose the port for first. The port is exposed based on the framework you're using. If you're using Django, 8,000. If you're using Flask, 5,000. I don't know. If you're using Java, 3,000. So you just keep on. If you're using Node.js, I don't know, it's 51, 53, something like that. So as you proceed with different applications, you just expose different ports. Then look at the application we are running. A microservice dot wsgi dot application. Let me tell you, if this one does not rhyme with setting here, utakuwa umerambwa vibaya sana. See this. And if this one does not rhyme with the name of like this one was with small letter M, hapo kaandika capital letter M, that one will not also not run. So inakuanga vitu miscellaneous sana, but very important. This one alone is enough for us to build the Docker image and push to the container registry in. So I told you we are going to stop when, if you come back on Saturday, is just to now provision the environment in Google Cloud Engine, then run the Docker file, push our to the registry, then go to the GKE, pull from the registry, then run our app, then get us the URL, come back to setting.py, implement the URL, then access the app. Then yeah, we are done. We will be done on Saturday. Okay, so we continue. The requirements .txt should contain Django, Django REST framework, pandas, numpy, scikit-learn, like in short, everything you may need. So just copy them there. Alafu, notice what has been done there. Meaning you will keep on updating. That's the monitoring part. And your is always very lazy. So what I do, I always remove this. My is equals, meaning that you are forcing it to, you are forcing the Django to use the exact, the very exact version, which means that when it has been upgraded, you sail backward. So I always remove this. But caution, when you're using the exact version, ensure that this exact version of scikit-learn rhymes with this exact version of Django REST framework. And that's why in my main app, I do not do that, because I know nitarambwa. Okay. Mbona iko kadogo hivyo? Sio hii. Please, sio hiyo. Okay, I just know where I'm going to get them. But this is not the requirement of TXT that, let me see. Oh, I think I changed everything, but it is in the other one. Let me find it. When you know your folders, it's very easy to find what you want. When you don't know your folders, itakuwa imekuramba. This one here, copy, should be now this here, paste, 127 of them. So as you can see, I did not enforce. Why? Because this Django may not be rhyming with this Django core headers, then in Akuramba. So what I did, I just leave it the way it is, so that when I install, Python is the one who is going to tell me. And if it installed the one that does not rhyme, I will see it in the error. But if it works well, don't touch. In my case, it doesn't work well. So I'm just trying to tell you that be careful when using the exact version, though it is also industry recommended. So at the end of the day, uko katikati ya a rock and a hard place. Aya. Niridmia huku. Uses Python 3 Slim for lightweight image, installs dependencies and runs the app with Unicorn for production. Then Docker container packages the app and dependencies, ensuring consistency across environments. The reason why Docker is important, imagine we've done this on Windows, but if someone is going to run this, like the VPS we are going to use is Linux, the GKE is Linux, everything is Docker anyway is Linux. So at the end of the day, you're just getting the same environment. Like Docker is going to help us that such that the environment is actually very, very dynamic with each and every. The environment will be very, very dynamic for each and when it comes to deployment. Even if you provision your app on Windows OS, the same thing will happen. So using the niliona umuhimu wa Windows OS, I told you the guys who gave me POC. So it means we are going to host for them the Power BI on Power BI on VPS. So kumbe Power BI only runs on Windows alone. So it means that of the VPS we have Windows OS installed and not Linux. Iliniramba. But anyway, it's okay. I don't want to talk about the deployment of YAML file before talking about the theoretical approach to Kubernetes. I'm requesting for lots of your time to explain this because it's still mingi. But lots of your time. I'm very specific. So I want us to stop at this point as far as practical is concerned, so that we can learn something about theory. Niko na notes hapa. The whole market shed notes. Yeah, it took me more than 4 years. So if you want to get it in, yeah, but you have to be consistent. And 4 years, not one. Like what I started with data analysis. So as we moved, then I went to data engineering. Then it is data engineering that told me, you know what, you need to know software engineering, because I was really struggling to understand the topic yanini. I was really struggling to understand the REST API. So when by then there was no AI. When I went online to search, I found someone saying that the only way you can understand REST API is by building REST API. I loved the advice. So you only understand REST API by building REST API. So that is by building a project. So I said, okay, let me give it a jab. And when I did PAP, it happened. Now, jamani, GitHub Actions. See, there was Kubernetes here. Okay. One day you might find yourself teaching. It's a good one, by the way. It's a very good one. It just it inaongezea knowledge kabisa. Because you must, first of all, you cannot teach what you don't know. So you must do research. Like yesterday, I didn't sleep. You can see what we did there. Credit, market share upskilling. By the time you're done with this class, you will be like, hey, ushaniimbia hii kitu itosha basi. You can tell him niko kwa class. Acha nimwambie. Acha nikupigie baadaye niko class please. Okay, I'm looking for it was here, GitHub, I mean Kubernetes. Here it is. Google Kubernetes engine and the concepts. Kubernetes is an orchestration platform for containers. We had talked about that sometimes back. That it automates, schedules, and run containers on virtual machines or clusters. So Google Kubernetes engine is a managed offering for Kubernetes. So Kubernetes itself was developed by Google, the company. Then when Google gave it to the Open Container Foundation, something like that. So you will go online and search for that information. Because of time, we cannot search for it. But right now, it is managed by I don't want to call it a foundation. it is not managed by Google. So this Kubernetes, you can, even if it is managed by a foundation, you can still deploy yours in your own VM and provision it to users as a managed version. So Google has its own managed version called Google Kubernetes Engine, GKE. So Kubernetes orchestrates, something that orchestrates basically provisions and speeds up. So when we have Docker file, having written the Docker file, what is going to orchestrate these Docker containers after building them? The Kubernetes is the one who is going to manage them. How is this going to do it? Immediately we are done with building the Docker machine, the Docker, sorry. Immediately we are done building the Docker image and pushing it to form a Docker container. Kubernetes is going to ensure that the images are actually copied into different clusters. Kubernetes works in such a way that if your workload is too high, you will have what are called clusters. A cluster is just a combination of servers. A server is basically the VPS, like VPS 1 here, VPS 2 here. Then this one will form cluster 1. Then this one will form cluster 2. Bringing us to the term of distributed computing. Kubernetes is a very, very important example of distributed computing architecture. So VPS 3, VPS 4. Such that when traffic is too high, Kubernetes will scale up to the 4 VPSs and it will distribute the traffic equally. So meaning when we build the Docker image, the image is going to be copied onto different VPSs so that when the traffic is too high or the usage of your application is too high, Kubernetes will distribute the traffic to the 4 VPSs. In contrast or contrary, when the traffic goes down, Kubernetes will scale down effectively to just 1 VPS or even to 0 based on the traffic. That is how important and very, very powerful Kubernetes engine is. Kubernetes has a manager that you can use to manage, a command line tool manager that you can use to manage called Kubecto. Depending on the size of your mouse, some people will call it kubectl. And when actually this one, IBM called it kubectl. When I heard Google calling it Kubecto, I loved it. I don't know why I loved it, but it sounds funny for me. So one day you may go to a company and stand in front of your engineers and say, so you're going to use Kubecto for this, and everyone laughs in the room. Hey, guys, are you laughing at a Google pronunciation? Like, but you can also call it kubectl. So I think this is more of formal to prevent embarrassment. Yeah, but let me now talk about Google Kubernetes Engine. It consists of clusters grouped together to, I mean, it consists of engines like VPSs, Google Kubernetes Engine that is, compute engines grouped together to form clusters. And this helps in cloud load balancing, node pods, automatic scaling that I've explained, automatic, by the way, this one is a pod. This one here is a pod 1. This is a pod 2. Automatic upgrades, node auto repair. When this one goes down, Kubernetes will direct traffic to this and this and this, then automatically prepare this before it brings it up again. Then logging and monitoring, you are able to see the health and how everything is happening in Kubernetes engine. In Google Kubernetes engine, we can put them in zonal clusters. Nimeenda bio sana. Iko tu sawa. Components, the cluster architecture, yeah, that is what we should teach. The cluster architecture. The cluster in Google Kubernetes engine, because that is what we are interested in. And by the way, I told you these cloud computing things, if you know one, working with the other becomes very easy. The only thing that changes is the name. Otherwise, the commands and everything, they are always almost similar. So when we have the GCP, this is the cluster architecture. This is a single cluster, and we say the cluster is composed of numerous compute engines or virtual machines. Compute engine is just a virtual machine. So when you come to this end here, you will find a cluster. A cluster, it will have what is called a control plane. Like the name suggests, the control plane is the one who is going to control where the traffic goes to different nodes or servers. So this is server 1, this is server 2, server 3. So the guy here is the man of the house. He will control where the traffic goes. It consists of a cluster can consist of one or more control is it plane or planes? I mean, it should be plane. Okay, one or more control planes. It also have one or more nodes, like we said before. And a control plane is responsible for scheduling and management. So it is the one that manages all the services and servers and pods there. The nodes run containerized apps. I was coming there. So when we push to this cluster, it will be taken to a node, and that is where the containerized application will run. Remember, this app has just containerized our machine learning model. So can you remember where we started from? From learning the theoretical approach and finding the best model and building it, and all the way coming, and now we are deploying it here. It will run on Google Kubernetes engine. Like, who leaves tech to go to medicine? Let's continue. My mom was really angry when I came to technology, and she was like, unaacha we mtoto unaacha udaktari. I didn't want to be a doctor from the word go. Then nodes are responsible for Docker runtime. Okay, components within control plane. In a control plane, the guy here, the man of the moment, let's call him the man of the moment here, we'll have the point of interaction with the cluster. Number one, we will have API calls, or what is called the kubectl or the kubectl. This kubectl, you can write a command on your local kubectl line to communicate with the one in GCP. How powerful! This is actually possible because of API calls. Then we have the kube scheduler. This guy is inside the control plane, and it discovers and assigns newly created pods. So if you create a new pod, the kube scheduler will scan through, and is the one who will discover that a new pod is here, then distributes traffic to it. Then the kube control manager. This guy controls everything, like the name suggests. Maintaining number of pods, access for namespaces, and etc. We also have the cloud controller manager. It runs controllers specific to a cloud service provider. For example, cloud controller for GCP will run just for GCP. By the way, in some big companies, they just don't use one, like XAI, where I might go if things go well. They use Google Cloud, but they also have their own cloud platform, which is for internal use. I'm told that, and I'm coming to learn of that. So, meaning, if they have their own, then the control plane will have a cloud control manager for Google Cloud, a cloud control manager for XAI Cloud, the same for AWS, and so on. Then there is something called etcd. Etcd is just as a database, a key value store that stores the state of the cluster. It will only tell you the state of the cluster, like it manages the metadata of the cluster. What is the health of the cluster? What is not happening? When did it go down? So that a cloud engineer will now come and see. A cloud engineer will now just come into the pod and view and see that at this and this time the pod went down, and that's why the app was inaccessible by the end users. Remember, the customers are the end users, and the other way around. Okay. I mean, there's something I wanted to teach it. I don't see it here, I guess. This not, see not, yeah, if the interleave is good, but you see by. Okay. Then we have what is called cluster node management on GKE. So which means that when we are going to deploy, the first thing we must do, we must create a GCP cluster or GKE cluster. That will be the first step. So when we provision a GKE cluster, it will automatically come with the control plane, and it will automatically come with the nodes, as you are going to specify the number of nodes. It's very important to specify the number of nodes, and so on and so forth. So the nodes will actually now form a cluster, and you are the one who is now going to manage them using the Kubector command line tool. Okay, then the custom node pods, useful for pods that require more resources like memory. Custom nodes are the user-defined nodes which you as the user, based on your app requirement, is going to define on GCP. So that based on, let's say if you know that you are working for Jumia, now umetoka market shed, you should not go and provision Jumia's app on 2 MBs or 2 GB memory. That one, leave it on market shed. When you are at Jumia, you now scale as Jumia. You create what is called a custom pod, and it can be manually or automatically upgraded. And like I said, automatically in that GCP itself is the one that is going to scan through and upgrade it based on traffic. Alafu there are cluster types. Number one, what we call the zonal clusters. The zonal clusters are in a single zone. For example, US East, that's a zone, one zone to share one class, and we are going to create a zonal cluster for our task because our work are in hata end user anyway. But if you are hired, ensure you create as per the requirements. In fact, no one is coming to advise you to do that. You are the one, in fact, to advise the management. So I feel like this app is going to be accessed by numerous guys. So I think we can do the multi-zonal cluster. In the multi-zonal cluster, what happens is that we will have a control plane here, then zone 1 of US and zone 2 of US. So zone 1 will have node 1, node 2, node 3, node 1, up all the way up to node K. You see? So that at the end, this is called multi-zone. But a single zone control plane here, then we just have node 1, node 2. And this is the one we are going to use. So these are the differences. But at the end of the day, control plane ni moja, but it is controlling the different zones. And you are accessing it by API call using the kubectl. We can also have regional cluster. The regional cluster can be done when you form different camps together. Single zones come together, CP, CP. So are you seeing the difference between multi-zonal and regional? There is here we have a single CP, but here we have numerous CPs managing the different zones under their own single zones. But you can also have your private cluster, where you, like us, we are going to do that actually, where we have the customer VPS outside, virtual network outside, then the Google managed cluster. So the two communicate. Our app on VPS and Google managed cluster communicate together. I think ni hayo tu for now. We shall start on pods. They say when you teach a lot, it dilutes the one that you had already taught well. So we shall start on pods and pod management, how we can manage pods, and we shall look at things called services, deployment, so that you get to know what they are. you must know what these things are: services, deployments, and everything. Like a service can be something like a database. That's a service. So that when we start deployment, if we write a YAML file, you don't look like a chick which has been rained on. Is okay. We can stop there unless you have any other question. So we meet on Saturday, 8 a.m.